Actually, I have now seen where the end of cancer is coming from. I've seen how the war is going to finish because I've had well over a dozen patients. And there are hundreds of people like this that are starting to form that can go from stage 4 cancer, that's game over cancer, to stage 0. We can do this. And not for everybody yet, but we're beginning to see where the light at the end of the tunnel is. And it involves your immune system. And some of the remarkable scientific breakthroughs are teaching us that our body heals itself against diseases as serious as cancer in ways that the pharmaceutical industry can't by itself do. But it really relies on the body. So when you talk about food as medicine or medicine as medicine, none of them are as powerful as what the body is hardwired to do by itself. In a 100 people who were receiving the responders study, the one microbe that dictates cancer survival immunotherapy for different types of cancer, that if you looked at the difference between people who responded, did well, versus people who didn't respond, didn't do well, died, all right? And that's the frustration with the types of treatments my mom had. Some people do well, some people don't do well. We pull our hair out trying to figure out like what's going on. How do we make people do better? Well, it turns out that when you compare everything, gender, age, corbidities, all the other genetic factors, the research that was presented showed that there was no differences between the groups of responders, people who did well versus people who didn't do well for immunotherapy, except for one thing. That one thing was one bacteria. The responders had one bacteria called Akkermansia mucinophila. So most bacteria have a genus and species. First name, where Akkermansia grows, a mapping of the human colon. Last name, first name is Akkermania. Last name is mucinophilia. Okay? It likes to grow in mucus. Mucinophilia. Where is there a lot of mucus? In the colon. Where's the colon? That's on this model, the blue area. So Akkermansia grows right here in the cecum, which is the pouch in the colon, right at the beginning before you take the up elevator to the top of the colon. That's where it grows. If the people had that Akkermansia, they would respond to immunotherapy. So what the researcher did, she took out the Akkermansia and brought it to her lab of the responders from humans and gave it to mice who were not responding to immunotherapy. Boom, she'd resurrect the immune response to kill the cancer. So this is one of the first bacteria, and there may be many, many that we haven't yet discovered. All right? So, like my whole career has all been about discovery. There may be more bacteria, but we discovered at least one, the presence of which seems to be absolutely vital if you are a patient receiving immunotherapy. The type of immunotherapy called DIY Akkermansia, the pomegranate, cranberry, and black vinegar protocol checkpoint inhibitors. If you want to tip the odds in your own favor of being a responder. Now, how do you get Akkermansia? Well, at the time, there was no Akkermansia probiotics. Now, you can actually find Akkermansia probiotics, but at the time this was coming out, you had to grow your own Akkermansia. DIY Akkermansia. All right? So how do you grow it? Well, it turns out that there are certain foods you can eat that grow Asia. What are those foods? Pomegranate juice. Pomegranate seeds will grow Asia. Cranberries, cranberry juice. Dried cranberries will grow Akkermansia. Concord grape juice or Concord grapes will grow Akkermansia. Chili peppers will actually grow Akkermansia. Chinese black vinegar. You ever go to dim sum and have soup dumplings? Oh yeah. The black vinegar sauce that they use for as a condiment to the soup dumplings. Chinese black vinegar. That will prompt the 10,000 daily mutations. Why don't we all have cancer? Your body to grow Akkermansia as well. Every day, every 24 hours, there are 10,000 mistakes that are made in your body that your body doesn't catch, that keep on that propagate in the document of our body as it goes on. 10,000. Each of those is a microscopic cancer. A microscopic cancer is just that. It's microscopic. It's too small to be seen with the naked eye, but it's abnormal. And that thing could turn into a big tumor that could eventually kill you. So why don't we die from cancer all the time? Now, this is actually something that I see as a physician. I have a patient diagnosed with cancer. They always ask me, Dr. Lee, why me? Why did I get breast cancer, colon cancer, pancreatic cancer, brain tumor? A very, very natural question, and I do my best to try to provide an empathic answer to that question. But as a researcher, I have a more interesting question. Given the number of mutations that occur in our body every single day, why don't we get cancer more often? Why don't we all get cancer as kids? You know, cancer can happen in children, but not as often as we have mutations. And it turns out this was the great unlock for me in terms of health. The reason that we don't become more sick from all kinds of diseases, including cancer, is the police cruiser analogy, how your immune system patrols microtumors because our body is hardwired with its own health defense systems, so that we've got these swashbuckling defenses that are firing on all cylinders all day long from the moment we're born until our very last breath. These systems that are inside our body defend our health, including the microscopic cancers, spots them, takes them out. Kind of like a police cruiser patrolling a quiet neighborhood, sees a drug dealer on the corner, pops them in the back of the police vehicle, and takes them away, cleaning up the neighborhood. That's how our body naturally cleans up these microscopic cancers. And so when you talk about cancer as a scary disease, you're thinking about the person whose body has failed to detect and eliminate the microscopic cancers, and it's become large enough to actually become a threat. Now, here's a question for you. So we tell women to actually do a self-breast exam when they're taking a shower. You know, look for lumps or the 1 centimeter barrier. Why palpable lumps? Already contain 1 billion cells bumps. And you know if you find one, certainly go to your doctor immediately for an exam. The smallest cancer that you could feel with a trained person can feel with their hands in the breast is 1 centimeter in diameter. A 1 centimeter breast cancer already has 1 billion cancer cells that have already multiplied. That microscopic cancer multiplied 1 billion times. That's the smallest one you can feel. Now, immune system's not taking that out, all right? So you need a better immune system if I want a shot at this and not just chemo or hormonal therapy. And that's where some of these incredible advances are taking place. But there's another one. In order to feed 1 billion cancer cells, you need blood vessels to feed them. So the cancers, as they get bigger, they hijack our own circulation to feed themselves, okay? It's kind of 100 million blood vessels. How tumors hijack angiogenesis to grow 16,000 times, like terrorists kicking in the cockpit door to take over the controls of the plane. They want to actually get your blood vessels to feed themselves. Now, normally the body knows how to control those blood vessels. It's called angioanesis. Angio, blood vessels, genesis, how the body grows and controls them. That's my area of research. So naturally, our body knows how to prevent blood vessels from feeding cancers and yet knows how to direct blood vessels to feed healthy tissues. So guess what? A 1 centimeter tumor with 1 billion cancer cells is fed by 100 million blood vessels coercing into the tumor to feed them. And we've studied this in the laboratory. The moment that a single blood vessel touches a tumor, tiny microscopic tumor, it will grow 16,000 times in size in just 2 weeks. So with this kind of knowledge, what can we do with cancers? Not just breast cancers, but in general. Number one, we know that if you boost your immune system with foods, with exercise, diet, lifestyle, you're going to actually make your immune defense is a lot stronger to patrol your body to wipe out those microscopic cancers. That's why healthy diet lifestyle lowers the risk of cancer. That's why eating the right foods that boost your immunity can substantially lower your risk of cancer, anti-angiogenic staples. Using coffee and tea to starve microscopic cancers as well. We also know that you can eat foods that support, prompt up, fortify your body's natural ability to control blood vessels. Keep those blood vessels where they're supposed to be and get rid of those blood vessels where you don't want them to be, which is kicking in the cockpit to take over your circulation to feed cancers. So if you eat foods like that are anti-androgenic foods, like unstable, you've got coffee and tea. Both of those contain natural substances that cut off the blood supply and starve cancers. That's a good thing. So that's why we know what we do with our diet can actually help to lower the risk of cancer as well. A study done by the Cornell Skinny Fat Study, tracking invisible visceral fat. Over 13 years, Cornell in New York, looking at Swedish women who were normal body size or skinny. So you've heard of skinny fat. This is what they were studying. And they looked at these women to see they did DEXA scans, as you described, to see how much body fat they had. And then they followed them over 13 years, and they actually found that women who did not have extra body fat had, normal risk of breast cancer. But women who had skinny fat, remember all the women in the study, and so 3,000 women actually were normal body size. They weren't super M models, but they were just normal sized women. Some of them were slimmer than others, but none of them were obese, none of them were overweight. You just normal size. But they knew at the B baseline what the DEXA scan showed. And what they found is that women who had excess body fat over the period of 13 years had a 3-fold increase in the risk of developing breast cancer, and it's linked to higher MET inflammatory markers in their bloodstream, which makes total sense. The leaking body cream, the leaking inflammation, in a skinny tube, all right, or normalized tube, pouring gasoline on embers, how internal inflammation promotes 14 cancers, normal suitcase. Look, the suitcase can't expand bigger. It's got a finite size, but it's leaking out. And this is because cancer thrives in an inflammatory environment. If you have inflammation with even a microscopic cancer, like we talked about, but a small tumor, putting inflammation in the environment of a cancer is like pouring gasoline on the embers of a fire. You ever go camping, you have a campfire, it's almost out at the very end. Now, if you pour some gasoline, it boom whoosh, you're going to have to create a bonfire all over again. That's how dangerous inflammation is. So that's why excess visceral fat, inflammatory fat, is so dangerous and linked to cancer. And by the way, not just breast cancer. It turns out that excess visceral fat has been linked to 14 other cancers. Increased risk of 14 other cancers. Everything from colon, ovarian, lung, breast, prostate. It's a growing list of cancers that seem to be you would be at higher risk if you had high levels of visceral fat. And it makes total sense given the inflammation. Hey, if you like that video, then you're going to love this one. Check it out.